Okie dokes. All right, so today what we did, or what we're doing, is looking at how to write an equation to represent a function. This is on page 32 of our Unit 7 packet. So writing an equation to represent a function is kind of like what we've been doing with finding the rule. Because once we find the rule, we then know how to get the output. And so to write an equation for a function, we kind of take the output and set it equal to the rule. And I'll kind of show you how to do that here. But what we've been doing with finding the rule is going to help us a lot out today. So if we look at this first example number 1, on page 32, we see the input, the output, the rule is blank. We're trying to find the rule. And the rule is going to help us find the equation, or help us write the equation. So first we have to find the rule. How do we get from 1 to 9? Well, we could add 8. 1 plus 8 is 9. Let's see if that works. 2 plus 8 is not 18. Well, we can also multiply by 9. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. And 5 times 9 is 45. So that means the rule is whatever x is, whatever the input is, we're going to multiply it by 9. So it'd be 9 times x. Because 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4. So these are all the connection between the input and the output is multiplied by 9. Now, the value of x, we'd say, is 9 times the value of y is 9 times the value of x. And if you look at this, y is the output. Y, or the output, is 9 times greater than the input. I like to think of the output kind of like the total. So this output is the total. This is the rule that helps us get to the total. When you write an equation, usually the total is by itself. So y is the total, and it's going to be equal to the rule. The rule is 9 times x. So if you look at this, like 9 times 1, that's the rule. 9 times x is equal to y. 9 times 1 is equal to 9. 9 times 2 is equal to 18. This part of the function is equal to the output. So the equation is y, which is the total. It's the output slash total. You can just put a little label there. Is equal to 9 times the input. So that's an example of an equation you could write to represent or to show a function. Let's try another one here. It's going to be similar probably to the last one. How can we get from 1 to 16? Well, we can add 15. 1 plus 15 is 16. 2 plus 15, though, is not 32. Let's try multiplying. 1 times 16 is 16. 2 times 16 is 32. 3 times 16 is 48. So it looks like the rule is you take whatever x is and you multiply it by 16. 16 times 1, that's 16. 16 times 2, that's 32. 16 times 3, 48. 16 times 4, and 16 times 5. Now, remember, the output is kind of like the total. And in an equation like this, the total will be by itself. Y is the output, that's the total. And what is it equal to? Well, it's equal to the input times 16. So whatever the input is, which is x, that's the input, you multiply it by 16, and you get the total. So that's an example of an equation. If you look here, like 16 times 2, that's equal to 32. 16 times 2 is equal to 32. 2 is the input, 32 is the output. All right, let's try another one here. 1 and 3. So to get from 1 to 3, you could add 2. 1 plus 2 is 3. 2 plus 2, though, is not 5. So let's try multiplying. 1 times 3 is 3. 2 times 3 is not 5 either. So this might be a two-step one. So then we look at the output, and this was the trick we learned when we did in the previous lesson, we look at how the output is changing. This is going up by 2, which means we'll probably have to multiply by 2. Let's try that. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. So it looks like the rule is whatever x is, we're going to multiply x by 2, and then we're going to add 1. So to take a look at that, see what that looks like. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5, and this is working out. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. And 2 times 5 is 10, plus 1 is 11. So it says the equation that represents the function would be, I don't know why I jumped right into this. That's the rule. We'll start with the output, which is the total. Output is y. That's going to be by itself. That's the total. It's going to be by itself. And it's equal to the rule. 2 times x plus 1. So you got the total here by itself equals the rule. So if x was 2, put 2 in. 2 times 2 is 4, plus 1 is 5, and we would get 5 as our output. So in the next examples, we'll see, notice that there's no space for the rule. We're still going to figure out the rule. It's going to help us write the equation. Now remember, the output is the total. And an equation like this, total, is going to be by itself. So we can already start the equation. It's going to be y equals something. Now we just got to figure out what the rule is. How do we get from 1 to 4? We can do maybe, and then 2 to 8. This looks like it's going to be multiplying by 4. So the rule for this one is whatever x is, you multiply it by 4. 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. So the total, or the output, is equal to 4 times the input, 4 times x. So again, the first step is to find the rule, and then we can make the equation. Let's try this one here. We'll start our equation. Y is the total. This is going to be the total. So that y is going to be by itself. That's the output. That's what we're getting. How do we get from 1 to 11? Well, we could multiply by 11, but 2 times 11 is 22, not 12. Let's maybe add. Let's try adding. 1 plus 10 is 11. 2 plus 10 is 12. 3 plus 10 is 13. 4 plus 10 is 14. 5 plus 10 is 15. So it looks like the rule is whatever x is, you're going to add 10 to it. So to get the output, which is y, output is equal to whatever x is, the input, plus 10. That's what it would be. All right, let's see about this next one here. First, we'll try adding. 1 plus 3 is 4, but 2 plus 3 is not 7. Or we can multiply. 1 times 4 is 4. 2 times 4 is 8. So this is probably a two-step one because adding and multiplying doesn't work for one number. Let's see what these go up by. That's going to go up by 3. So that means we're going to multiply by 3. So the rule is whatever x is, we're going to multiply x by 3. What's 3 times 1? That's 3. Plus 1 would get us 4. So I'm thinking maybe it's times 3 plus 1. 2 times 3 is 6. Plus 1 is 7. So it looks like the rule is whatever x is, we're going to multiply it by 3 and then add 1. So that means the equation is going to be y is by itself, y is the total, the output, is equal to, well, you multiply the input by 3 and then you add 1. Now the next ones we're going to do are a little tricky because the numbers jump, the input jumps up a little bit, okay? So something like this. Notice the input's going up by 2 this time. Normally it only goes up by 1. Normally it only goes up by 1. So we'll see how this works for this one. So first I'm still going to do the same thing. I'm going to try multiplying or adding. So 2 times 6 will get me to 12. 4 times 6, 24. So it looks like this is a one step. 6 times 6 is 36. So it looks like the rule is this. This is the total, remember? I'm going to set my equation up. The total is y. Y is going to be by itself. The total, the output. The rule is whatever the input is, which is x, we're going to multiply it by 6. That's how we get from the input to the output. So 6x, or 6 times x, is the rule. That's going to be equal to y, which is the total or the output. Now this one might be a little trickier. Okay, so we got 3, 6. These are going up by 3. How do we get from 3 to 11? We could add 8, but then 6 plus 8 is 14. So we can't really multiply by a whole number to get from 3 to 11. So let's see if we can multiply by something. Maybe multiply by 2. Let's try 2. 3 times 2, because again, like you can't use the trick here because these numbers are going up by 6, but these numbers are going up by 3. So this trick for finding like the rule only works when the input is going up by 1. The input is not going up by 1 here. So let's just see. Let's just try it. If we went up by 6s, let's multiply by 6 and see what happens. 3 times 6 is 18 minus 7. I don't know. So let's try this one. So we multiply by 6 and then subtract 7. 6 times 6 is 36 minus 7 is not 17. So that's why this one's a little trickier. Let's try times 2 though. If we multiply the input times 2, 3 times 2 is 6 plus 5 is 11. So times 2 plus 5. Let's see if that works. 6 times 2 is 12 plus 5 is 17. 9 times 2 is 18 plus 5 is 23. So the rule is this. You're going to multiply by 2 by the input, and then you're going to add 5. Now, there's not going to be one like this, like on like a test, okay, where they're skipping by the inputs going up by a different number than 1. But I just wanted to show you what one of these might look like, where you can't necessarily just use that trick because the input's not going up by 1. So the equation would be the total, which is by itself, which is y, equals 2 times x plus 5. Okie dokie. Let's try this one here. Same thing, it's going up by 2s. This is going up by 8s. Okay, let's see if we can try it in one step. Times 5, 2 times 5 is 10, 4 times 5 is not 18. You can't do add 8 either, that's not going to work. So here's one way to think about it. This is going up by 8. This is going up by 2. So what's 8 divided by 2? It would be 4. So that's what we'd multiply by. Again, this is not going to be something like that. It's not going to be on the quiz where it's going, or the test where it's going up by 2s. So let's try times 4. 2 times 4 is 8, plus 2 is 10. 4 times 4 is 16, plus 2 is 18. So it looks like the rule is you multiply by 4, and then you add 2. Let's check it with this one even. 4 times 10 is 40, plus 2 is 42. So y, which is the total, is equal to 4 times x plus 2. Now, for the next thing we're going to do, we are going to need a ruler or a straight edge, something to help you draw a straight line. So if you don't have one available, pause it and go get one, because we'll need one for what we're doing right now. So what we're doing is we're taking an equation, like the ones we just wrote, and we're going to graph it. Okay? So the first thing we have to do is find what are called the ordered pairs, or the points we're going to use to graph. So to do that, we're going to pick 3 numbers as our input. So we're going to graph this function, or this equation, y equals 2x. So whatever the input is, we're going to multiply it by 2 to get the output. Now, when you're making a graph, the inputs you want to pick are you want to pick the easiest numbers to work with. So I want to pick 0, 1, and 2. Those are the easiest numbers to start out with. Always pick those 3 if you need to make a graph. So if the rule is times 2, To get our output, we'll do 2 times 0, which is 0, 2 times 1, which is 2, 2, and then 2 times 2, which is 4. So then our ordered pairs, an ordered pair is an x and a y. And you can see here, here's our x, here's our y, x, y. So the ordered pair is always in that order. First x, then y. First the input, then the output. Input is 0, output is 0. That's called an ordered pair. We use parentheses to show an ordered pair. Input is 1, output is 2. That's our next one. Then input is 2, output is 4. So now what we're going to do is we're going to graph the ordered pair on the little graph here. So the first number is always the x. Here's the x-axis. Here's the y-axis. So the first number we find is the 0x. So here's 0x, and we're going to go up 0y. So that is our first point here. There's 0, 0. It's called the origin. Our next point is 1, 2. Okie dokes, here we go. So our next ordered pair is 1, 2, meaning x is 1, y is 2. So on the x-axis, we'll go to 1, and on the y-axis, we'll go to 2. 1, 2. Our next ordered pair would be x is 2, y is 4. X is 2, y is 4. Now look at that. That's an example of a linear function because we can take your little straight edge, whatever it is, make that into a line. We'll put an arrow right at the end. That's called a linear function because it makes a line. All right, let's try another one like that. If you can see that. I don't know if my camera was off a little bit. Okay, let's try this one here. So here's our new equation, y equals x plus 1. We'll pick our inputs, 0, 1, 2. I would always pick 0, 1, 2. Our output is going to be, well, if x is 0, 0 plus 1 is 1. 1 plus 1, the output would be 2. The rule is x plus 1. 2 plus 1 is 3. So then our ordered pairs, remember, ordered pair is an x, y. X goes first, then y. X goes first, then y. X goes first, then y. Okie dokie. Now, when we do our graph, same thing. X goes first, then y. Here's the x-axis, here's the y-axis. First number, x is 0. So here's where an x is 0, and then y is 1. So this is when x is 0, y is 1. So there's going to be a little point there. The next one, x is 1, y is 2. There it is. X is 1, y is 2. And then the last one, x is 2, y is 3. And look at that. Another linear function. So the linear functions we're going to work, or the functions that we work with in 6th grade are all linear. So if you ever don't have a straight line or a diagonal line like that at the end of it, you may have made a mistake somewhere. Okay? All right, let's try another one. Again, we can pick any inputs we want, but let's pick the easiest ones. 0, 1, 2. So if x was 0, 0 times 3 is 0, plus 2 is 2. If the input's 1, 1 times 3 is 3, plus 2 is 5. 2 times 3 is 6, plus 2 is 8. All right, so there are ordered pairs. Again, that's x, y. We can just write them on the side here. Always goes x first, then y. X, then y. X and y. Let's put them on the graph. Okay. First one, here's the x-axis. Here's the y-axis. So we'll do x first. First order pair 0 over 0, and then up 2. 2 is y. So 0x, 2y is going to be right there. 1x over to 1, and then up to 5. 1, 5. Hopefully this makes a straight line. Over to 2, up to 8. There it is. This looks linear to me. Whoop. Okay, that's linear. All All right, we're just going to try a couple more of these. Now, you can try these ones on the back on your own if you feel comfortable doing so, or you can do them with me. So the inputs, again, I'm just going to put 0, 1, 2. All right? This should be a y here, by the way. So if x is 0, 0 plus 3 is 3. 1 plus 3 is 4. If x is 2, 2 plus 3 is 5. So again, our ordered pairs, x and y, are 0, 3, 1, 4, 2, 5. Let's graph it. All right. 0, 3. That means at x-axis is the side to side, horizontal. Vertical up and down is y. So we'll go over 0 and then up 3. That's our first one. Over 0, up 3. Over 1, up 4. So over to 1, 1x, up 4y. Over 2, up 5. And again, I'm pretty confident in this because it makes a straight line. So that's linear. Oh, yeah. Put the arrowhead at the end. That's going to keep on going forever. All right, just a couple more here. So again, input, 0, 1, 2. Output, 3 times 0, 0 plus 1 is 1. 3 times 1 is 3 plus 1 is 4. 2 times 3 is 6 plus 1 is 7. So our x, y, our ordered pair is going to be 0, 1, 1, 4, 2, 7. Let's graph it. Okay, so we got x here. That's x. That's y. Over 0 on x, over 0, and then up 1. Up 1 right here. So over 0, up 1. There it is. Over 1, up 4. Ta-da! And over 2, up 7. Again, feeling good, linear. We can draw a straight line. In this case, it'd be diagonal, but that's what it would look like. Okay, there it is. Linear functions. All right, last one. Again, we'll put in 0, 1, 2. Let's find our output. 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 would be 7. Okie dokie, okie dokie. Let's do this. So x is going to go here, y is going to go there. Let's graph. First, I'm going to make my order pairs. I almost jumped the gun there. So 0, 3, 1, 5, 2, 7. So the first number is x, goes side to side. So over 0, up 3 would be right here. Over 1, up 5. Okay. Over 2, up 7. And again, feeling great. Got a linear function. Pretty good. So today was a couple new things, writing an equation and then using that equation to graph. Those are the two things we did today. If you had any trouble with any of this, let me know. If not, hope you have a great day, and I will see you soon. Bye-bye.